Hey guys, so today we are going to go over derivatives of trigonometric functions. So we've already gone over the rules such as sum, power, product, quotient, and now we're going to apply them with the trigonometric functions. So a couple of things that we're going to just post reminders of here are the common derivatives such as the trig functions, as well as the beloved unit circle. Remember that you learned how to read this in pre-cal and for some of you in algebra 2. Um, so we're going to start here. We're given a function f of x. They're asking for f prime of pi over 4. So f prime means that you're finding the derivative. So I'm going to start there. Since I have f of x, to find f prime of x, I am going to take the derivative using the sum, taking the derivative of each term. So the constant is 5. I can bring that down and take the derivative of sine of x, which is just cosine of x. And then separated by the plus sign is another term in terms of x. That'll be cosine of x. And if you look, the derivative of cosine of x is negative sine of x. So rather than write plus negative sine of x, I'm going to rewrite that as minus sine of x. Now they want to see what pi over 4 is. So notice that all I'm doing for f prime is I'm replacing the x with pi over 4. So same deal here on the other side. I'm going to replace the x with pi over 4. All right. So from here, we're going to take 5 times the cosine of pi over 4. Pi over 4 is the angle here. Please remember, cosine is the x value, sine is the y value, and tangent is the value in red by itself. So the cosine of pi over 4 is square root of 2 over 2. Minus the sine of pi over 4. So we're going to the same angle. The sine value is the y value. It's also square root of 2 over 2. And using PEMDAS, we would multiply straight across. So fraction form of 5 is 5 over 1. That would give me 5 square root of 2 over 2. Bring down the second term, minus square root of 2 over 2. You could see the answer written this way. Again, some of your assignments have multiple choice answers, so you could see the answer this way, or notice how you are subtracting and they already have a common denominator. So you can keep the common denominator and just combine the numerator together, which would give you 5 square root of 2 minus square root of 2. Now, this may not look like it, but they are like terms in the numerator because they both have square root of 2. It's like subtracting 5x minus x. So remember, in front of that x is a 1. I keep the like term, which is x, and 5 minus 1 gives me 4x. So same deal here. I'm going to keep that like term, which is square root of 2, and do whatever the coefficient is, and this is 1 in front, so 5 minus 1 gives me 4 square root of 2 over 2. You think we're done? Not quite. 4 over 2. Remember, there's nothing factored that needs to be factored out because there's no plus or minus. So there's nothing to be factored out to divide out. You can just divide it out. You have 4 over 2, and that gives me 2. And then I'm going to bring down the square root of 2. And since I'm out of room, I'm also going to put the answer just right there. So 2 square root of 2. And that is the end of the algebra. All right, guys, hope this helps.